Hello, I Anand Jain from Hanumangarh, Rajasthan welcomes you to your favorite Shridevi classes YouTube channel where we inculcate interest and confidence in science, engineering and architecture subjects. Today in our playlist of green building, we'll understand design feature of fenestration and we'll understand different climatic zone of India and as per climatic condition how fenestration can achieve better daylight, cross natural ventilation and comfortable temperature conditions inside any building. So let's understand design feature of fenestration. Envelope of a building includes all outside walls, doors, windows, glass panels, roof or any skylight used in house design. This building envelope acts as a protective skin for resident of house and it also determines the comfort level of resident at different time of day or in different seasons of the year. Doors, window, glass panels, skylights are opening in the building envelope that generate transparency on a particular building face, and this transparency provide natural daylighting, natural cross ventilation and most optimum temperature conditioning for indoor space. These openings also provide connection to outdoor conditions and access to building from outdoor. These fenestration play dual role of bringing the outside condition to inside and inside conditions to outside. These fenestration also decide the energy performance of building during its operation and they also influence the aesthetic value of building. Two primary consideration in the design of fenestrations are orientation of fenestration and sizes of their opening. A well-designed building envelope and fenestration follows the trajectory path of sun around building, the flow of natural wind across building and heat pattern of climate, and appropriate design of building envelope and fenestration improve comfort conditions of inmates and also reduce energy use during building operation. A good building design always respect factor like climate of place, local building material, local nearby landscape and living style and functional requirement of people who use this building and other physical attribute of the site. Here this is a north facing part of building and maximum positions and size of fenestration is provided on this north facet of the building, and this is as per the design requirement for energy efficient green buildings. The prevailing climate in most Indian region fall within four popular categories. One is hot and dry region, major part of Rajasthan, a part of Gujarat, Madhya Pradesh and a considerable part of Maharashtra, shown here by a red boundary, is hot and dry region. There is a large coastal area which is warm as well as humid and it include entire Tamil Nadu, Karnataka, major part of Andhra Pradesh, Jharkhand, West Bengal and Northeast India. We have a composite region surrounding Delhi or in northern plain where we see both hot and dry condition as well as cold conditions, and we have a small hilly area of Jammu and Kashmir, Himachal Pradesh, Uttarakhand and Arunachal Pradesh where we have cold climate conditions. In hot and dry climates, air carries intense, dry, uncomfortable heat and smaller opening distributed throughout the facade can reduce volume of heat entering the building and provide the necessary cross ventilation and daylight conditions. In hot and dry climate, solar shading across fenestration is utmost important, and for that we use such lowered or latticed fenestration are excellent choice to block direct sunlight in hot and dry climates. In desert-like climates, if fenestration provide natural ventilation, then that ventilation can also bring with it some unwanted heat and which can cause severe discomfort to residents. So, appropriate control of shedding on fenestration is also required in desert-like conditions. So, we have to adjust fenestration opening in those conditions. In warm and humid climates, such as coastal part of India, the cause of discomfort is excessive humidity with high temperature. And in such warm and humid climates, the movement of natural wind flow or cross ventilation is very important criteria in effective fenestration design. And in building envelope, doors and window should face the direction of wind which flow from southwest to northeast direction. So we provide doors and window in fenestration in those directions to allow maximum natural cross ventilation. Now such fenestration should avoid direct sunlight from eastern face or western face or southern face. By appropriate shedding on fenestration, we can also achieve good ventilation through the roof, and that can be achieved by use of skylights. Additionally, to improve ventilation, we can provide courtyard or atrium in building design as open space for both natural ventilation and light penetration. Designing a building fenestration for a composite climate is a challenge since the building experience both extreme hot condition in summer and extreme cold condition in winter. The spring period in between summer and winter is especially suited for natural ventilation, where natural cooling without use of air conditioning can be used. But for other extreme conditions, we should provide maximum opening in north face and south face and in southern face to avoid direct penetration of solar radiation inside the working space. In summer conditions, we must provide horizontal projection over fenestration as shedding, and they may be permanent overhangs or temporary shading arrangements on fenestration so that we can stop summer solar radiation by shedding and low angled winter radiation, which can generate comfortable temperature conditions in indoor space, can be allowed to pass fenestration, as these horizontal shadings won't obstruct winter low angle solar radiations. In cold climate region, the window fenestrations got dual feature. They use passive solar space heating. That means they allow admission of solar heat from solar radiation to internal positions, and they use appropriate insulation in building envelope as well as on fenestration to prevent heat loss through window during cold conditions. In cold climate, to have maximum solar heat gain factor, we use maximum window area with large head in south face of building for direct solar heat gain, and in fenestration we use double or triple glazed sealed window to reduce amount of heat loss in fenestration. In cold climates, on fenestration, double glazed window with thermal insulation between glass panel and metal frame is used, and in between two panel of glazing insulating gas either argon or krypton is filled. Now in this glass panel, special low emission coating is provided on glass panel facing solar radiation to inner side, and this will have high solar heat gain coefficient, and roughly 40% of solar radiation falling on window section penetrate it and go inside to create required heat gain. The two panel got very good visible light transmittance, and it is 60% or above, and this special low emission coating reflect good amount of heat back, and that results in lower value of U factor of this double or triple glazed glass panel used for doors and window in fenestration. Apart from special E coating and argon or krypton insulation in between gap, the thermal insulation frame all should be completely airtight so as to reduce all possible heat loss. in these fenestrations or other openings, we can also use sliding screens that are open or removed from window fenestration in daytime, and in night hours the sliding screen is placed on fenestration so as to retain indoor heat, and we can use such sliding screen with sensor and automatic operation, and as per presence of daylight these sensors operate automatically the sliding screen on window fenestration. To ensure thermal comfort inside building, we must understand heat transfer through envelope during day hours. When external temperature is higher than internal indoor conditions, heat will transfer from high temperature to low temperature from external environment to room, whereas in night conditions the same heat of internal condition transfers to external environment, and if building envelope is poorly designed, then this may cause great discomfort, especially during harsh peak summer days or a very harsh winter day when the difference between external temperature and internal temperature is too much. Well designed fenestration ensure thermal comfort for indoor positions, but apart from temperature conditioning, fenestration also ensure natural uniform daylight. Daylight enters in internal spaces through window or glass panel or fenestration, and well designed fenestration with appropriate shade and good orientation of room can improve quality of daylight in indoor space. Good uniform daylight reduce energy bill of artificial lighting, and that also promote physical and mental well-being that enhance creativity and productivity of inmates. North facing fenestration provide ample amount of daylight, but they won't contribute anything to heat up internal space. South facing window provide ample amount of sunlight, and they also heat up internal space, especially during cold winter season, and this shading by horizontal projection on fenestration restrict summer heat to penetrate inside this south face. In passive solar design, this horizontal shading keep unwanted summer sun out, and same sun radiation in winter, which are at lower angle, allowed into the building by this fenestration. In good solar passive design, we should avoid direct sunlight from east or especially west facing fenestration, as west facing window brought both heat and glare, and that should be avoided, or we must use appropriate shading to restrict entry of heat from west face. For optimum utilization of solar radiation for natural daylight and temperature conditioning, we must select appropriate orientation for different spaces of any house. In a house, the spaces which are more frequently used during day hour, such as kitchen, living rooms, they should face north direction or south direction for required daylights, and such spaces should be designed away from rising sun from east face or setting sun of west face, and for such spaces which are in north or south face should have window opening to outside to get daylight, and from south face they got both daylight as well as desired heat of winter season, and appropriate shading in south face reduce direct penetration of solar heat into internal spacing in south face in summer season to reduce unwanted solar heat gain. In north facing window or other fenestration will get uniform indirect glare free light, which is very comfortable, and it require minimum shading arrangement. So we should provide large openings in northern face and with heavy shutters on western face to restrict penetration of direct sunlight from western face during sunset conditions. So northern face of building doesn't require any specified shading, and with minimum shading we will get well desired uniform daylight without solar radiation, whereas in southern face we should use extended roof or horizontal overhangs over window and doors for effective shading of overhead afternoon sun in summer. And in east and west face we must use horizontal fins or a combination of horizontal and vertical fins for protection from rising sun in eastern direction and setting sun in western face. Use of high window, clerestory near beam or north facing window with reflective shades and proper arrangement can improve quality of daylight and will get higher and uniform illumination over the working space. And we can integrate courtyard in building to improve quality of daylight in our building. In indoor space, due to respiration process of inmates, the level of CO2 in internal air increases. Along with increase of CO2 in air in internal conditions, the body odor produced by inmates, moisture and other pollutants within the indoor condition of house make the air inside stale, and breathing that stale air is unhealthy. To refresh stale air for healthy breathing condition in indoor positions, a typical office space would require purging or suction of fresh air of about 15 cubic feet per minute per person. And to maintain freshness in internal space, the stale air inside is replaced with fresh air from the external environment through window, door opening and other openings. And if this is achieved without any artificial fence, then this replacement of stale air by fresh external air is called as natural ventilation. In hot and humid places such as Indian coastal, natural ventilation in buildings also helps to bring the temperature down to comfortable position. And for good natural cross ventilation in any house, we must use the direction of breeze, and for most of the positions breeze flow from west to east. So breeze enters in a building from west and south positions and it leaves from east and north position. And for effective wind circulation, the window area on envelope should be 15 to 20% of floor area of the building. Window openings in building envelope are positioned along the direction of natural breeze outside in the surroundings, and these windows should be positioned at suitable height as shown in this diagram below, so as to allow air to flow at body level. For good design, the sill height of window or the lowest position of window should be at low level between 0.5 to 0.7 meter. For windows of southern and western side, suitable radiation barrier in the form of canopies, chhajja or long veranda should be provided on fenestration. For exhaust of hot stale air, sufficient number of ventilator close to the bottom of slab should be provided. When wind flow in from one side, say west side, and circulate through the space and exit from opposite side, say east, then it is called cross ventilation. And apart from cross ventilation, the air also distribute and circulate in internal spaces. So just opposite facing to each other window opening is not desirable. Any obstruction very close to windward direction is undesirable, and if that obstruction is away from windward direction of window, then it will ensure good circulation and distribution of air in internal space. If windward and leeward directions window are very close to each other, then majority of room space remain deprived of air circulation, and if we place windward and leeward window quite far away in room envelope, then it will ensure good distribution and cross ventilation. For good swift movement of air, the windward opening should have smaller cross section, and leeward, where wind go out of room, should have a larger cross section. For cross ventilation throughout the building, windward window of west and south and leeward window of east and north won't have any obstruction in between, and for that internal doorways between drawing and dining or passage must be left open without any shutters or leaves, so that wind movement naturally take place without any obstruction. High opening such as clerestory windows and ventilator acts as effective exhaust for hot and lighter stall air. During building operation, warmer air being lighter moves up, and when it escape out from ventilator or clerestory window, then from bottom side cooler air naturally come inside, and by heating, when air become hot, it rise up and goes out from ventilators, and this effect is called as stack effect. And for good stack effect, ventilator should be provided as near to ceiling as possible. For greater comfort of inmates, mechanical ventilation for circulation of fresh cool air as well as for exhaust of hot stall air should be made by mechanical means, and from fresh air conditioned supply duct, suction of cool fresh air should take place, and by use when it become hot, ordered and stall, and by stack effect rise, then from bayonet warm air through suitable openings in false ceiling. This stall air is extracted out through extract duct by mechanical means, and this mechanical ventilation enhance air movement, temperature conditions and working environment for inmates. For speed up of air circulation or air flow, the windward opening should have a smaller cross section, and leeward exit opening should have a higher cross section in opposite wall, and this smaller in and larger exit enhance air movement in indoor conditions, and this engineered wind flow traditionally practiced with jalis in hot climates to enhance ventilation for better cooling, as it is utilized in famous Hawa Mahal of Pink City, Jaipur, where small opening and jharokas for air intake got opposite face large opening, and this enhance air movement behind this fenestration in indoor conditions. We hope this beautiful learning video has explained all design feature of fenestration for natural daylight, optimum temperature conditioning and cross ventilation in our buildings. Our other learning video of the same green building playlist are equally useful, and if you found them useful, do use them in your studies, and you can also share them to your friends. Happy learning, have nice time. Thank you very much.